last video, we saw on how to convert a binary number to decimal, octal to decimal, and hexa to decimal. We also saw how can we group bits together to go from binary to octal and binary to hexadecimal. This video covers on how to go from a decimal number to a binary number. And you're going to learn two ways of doing this. The first one, descending power and subtraction method. The second one, division with remainder. Let's go over the first method, descending power and subtraction. I have my decimal number, 200. I'm going to write the binary weights, and I'm going to write the respective decimal weights. This is going to make my life easier. And I'm going to write my binary number over here. The first thing that I do is I compare 200 with the most significant bit, 512. Is it greater or equal? If it's not, I get a 0 and I keep going. Is it greater or equal than 256? Nope, I get a 0. Is it greater or equal than 128? And their answer is yes, so I get a 1. And I subtract that decimal weight to 200, and now I propagate the 72 to the rest, to the other bit. Is 72 greater or equal than 64? That is correct. I get a 1. Subtract 64 from 72. I get an 8. Now I pick up the 8. Is 8 greater than 32? No. I get a 0. Greater or equal than 16? No. 0. Greater or equal than 8? That is correct. I subtract 8. I get the 0. And I know that the 0 is not greater than any of the rest of the numbers. I'm going to put the other two zeros over here, and this is my binary number. Your number 200 in decimal is equal to 11001000. Let's go over the other method, the division with remainder. In this case, you're going to compute a bunch of divisions. I pick up my number 200 and I'm going to divide by 2. And why by 2? Because this is my base of the number that I want to convert, which is the binary number. 200 divided by 2 gives 100. The remainder is 0. And I keep doing this operation. 100 divided by 2 gives you 50. Remainder 0. 50 divided by 2 gives you 25. Remainder 0. And now 25 divided by 2 gives you 12.5. Because I cannot represent the halves, I put the 12, and the 0.5 is going to be your remainder. In this case is 1. Remember, binary numbers, either 0 or 1. 12 divided by 2 gives me a 6, remainder 0. 6 divided by 2 gives me a 3, remainder 0. 2 divided by 3, 1.5, so I get a remainder. And 1 divided by 2, 0.5, so I get the 0 and the remainder 1. And now I read my number from bottom to top, and you get this binary number, 11001000. In summary, we saw the 4 most common bases used in Inter-to-Mechatronic systems: 2, decimal base 10, binary base 2, octal base 8, hexadecimal base 16. We saw on how to convert a binary number to decimal and how to go from binary to octal and hexa numbers. We also saw how to convert decimal numbers to binary using the descending power and subtraction method and the division by 2. And when you are converting binary numbers to decimal, you can use this method here called the 421 or the 8421 codes, that all is doing is just using the binary weights. So I know 1, 2, 4, and 8 to make that conversion easy and fast.